Continuing on our topic of security, we're going to take a look at another attack vector that surprisingly quite a few websites still have and is very easy to prevent in ASP.NET MVC. First though, I would like to point out we did not actually commit in the last video. We did that off screen, but make sure you guys do that on your own projects. Okay, so the attack vector we're going to be talking about is CSRF, or Cross-Site Request Forgery. What that means is it's actually really bad. This is
Yeah,
like
Nelson was telling me about it, and I'm just terrified right now.
yes, CSRF is a very very bad attack that most websites are open to. So we're going to talk about what the attack is and how to prevent it. So CSRF, or Cross Site Request Forgery, is when a malicious website sends a request to a legitimate website that you're logged into. So, for example, let's say we have a bank. And let's say we have a user. Now, when the user logs into the bank returns an authenticity token in the form of a cookie. So we'll just call that an auth cookie. Now, every single subsequent request that the user makes to the bank will actually have the auth cookie inside of it. So let's just say that the auth cookie is this little square right here. So that's the auth cookie.
Alrighty.
And so because every subsequent request the user makes to the bank's website has the auth cookie, the bank will validate that request and allow the user to perform any action that he would be able to, right?
Right.
Now, what happens if the user visits a bad website? After he's established his auth cookie. Well, the bad website can have a form on it. It doesn't even need to be a form. I'm just using this as a kind of visual example because we can certainly have the bad website use JavaScript to do this without the user's knowledge. But for the sake of this example, let's just say the bad website has a form on it with a nice big submit button. This is the nice big submit button, right?
Right.
Now let's say this form is malicious. Let's say this form actually posts to bank, as in its action equals the bank's website. So let's just say bank.com. What happens when the user clicks this button?
That talks to the user and gets that authentication cookie before it talks to the bank.
In a way,
Sort.
yes.
Yeah.
This request, because it has an action of bank.com, literally goes all the way out and hits bank.com, and guess what it brings along for the ride? The auth cookie.
Yeah.
Yep.
Oh, that's scary. It's scary, Nelson.
It is scary. So this makes three assumptions. The first assumption is that the user is logged into the bank. Fortunately, banks have security in place for this. It's unlikely you'll find a bank that has this particular attack, but I like to be sensationalist when I do little security presentations. So we're just going to say that it's a bank that has this vulnerability.
So each of you watching this, we're talking about your bank.
Yes, your specific bank. And so this assumes that the user is logged into the bank and their auth cookie has not expired. This assumes that the bank has the vulnerability, and this assumes that the user goes to a bad website and the bad website is able to submit a request to the bank. And remember, this is all done in the user's browser, and the user's browser will always send the auth cookie to the bank whenever it makes a request to the bank. Now, the bad website doesn't have direct access to the auth cookie, but the user's browser does. So when the bad website posts to the bank, that auth cookie comes along for the ride, and hey, look, we now have transferred our entire account to another bank account.
And this is where on break I shut down all of my online banking.
Exactly. So the attack is basically just tricking the user's browser into making a request that isn't legitimate. That's why it's called cross-site, because it requires two players. It requires the bad website and the good website, and they're different. It's making a request, but it's forging that request. It's forging because it's making a request the user did not intend to make. Now, of course, the bad website has to know about how the bank works. It has to know exactly what form fields to fill out and how the bank's forms work and what URL to post to, but really that's not that easy to figure out. Just log into the bank on your end, write down, all the little fields and form fields and URLs, and then craft a bad website that posts to that from any user that logs in.
Yeah, still terrifying. Sounds hard, but it's not that hard and still terrifying.
Yeah, it's very easy to do. So why or how can we prevent this? The most common preventative measure is through the use of an anti-forgery token. An anti-forgery token is a special little bit of data that's randomly generated at certain times. Well, what do I mean by that? Well, let's just move that off to the side for a second, and let's talk about our web server. We have a user. We'll call him user 1. And let's say that when he logs in, he gets a anti-forgery token, which we're just going to have XXX5Z. That's his cryptographically generated random user anti-forgery token. So this is a number that is associated on the web server with the user. Every user has a different anti-forgery token. When the user's web browser goes to create or view a form on the web server, so when the web server presents a form to the user, it actually will hide that token in the form somewhere, hidden from the user. When the user then clicks the submit button, so here's the awesome submit button.
Yep, our big submit button.
When the user hits that and the form gets sent back to the web server will verify that the token sent in the form is the same token that's associated with the user. Now this is a little simplified. Some websites regenerate anti-forgery tokens for every form that's submitted. Some websites will only generate one when the user logs in, and some websites will generate one at periodic intervals. But the point still remains. The point is that the bad website can never know what this token is.
Or even if it's there, right?
Yeah, or even if it's there. The bad website doesn't know the user's specific token. Well, it could know that it's there because all it would have to do is log into the bank, look at the bank's hidden fields, and see if it even generates one.
Gotcha.
And then it knows that it uses this technique, and it should just give up because there's no way it's going to break it.
Gotcha.
So, again, the point of this is that this site does not know, is completely in the dark of the anti-forgery token, and therefore is unable to perform this attack. Now, there are some limitations. The first limitation is bugs in browsers. If there's a bug in a browser that allows the bad website to load up another website on the user's behalf, it could sniff out the anti-forgery token. That being said, those bugs rarely, if ever, exist on browsers, and they get fixed up immediately because they break all forms of security.
Okay.
Second thing, these tokens don't really work on GET requests. That's why we hide every single thing that actually edits data behind a post, because post requests are the only requests that can be protected from this kind of attack. And finally, with ASP.NET MVC's implementation, you're going to need cookies installed in your or enabled on your browser. But if you have an auth cookie, you obviously have cookies enabled.
Okay.
Okay, so does this kind of make sense?
Absolutely.
Okay, well, let's go ahead and see how to implement it, because it's very, very easy. And we're going to be doing this on all of the forms that we have. So I'm going to go back into my code, and I'm going to go ahead on my HTTP post on my new, in my user's controller, I'm going to add a new filter, and it's going to be validate anti-forgery token. If I build and come back into my users admin and refresh so we know the server's alive. If I go to create a new user, well, look what happens.
It kicks it out.
Yep.
Gives you an error.
There's no way for us to submit this form without the anti-forgery cookie. Or, well, specifically the request verification token. So how do we generate the request verification token? That's also very easy. Let's go down to our form inside of our views, users, new, and let's just at the top of this form type in html.anti-forgery token. Well, that was easy.
That was very easy.
Let's come back to our page, refresh, and look at the source code. Look at that. That is our request verification token. It's been generated for us by ASP.NET. It's a cryptographically secure random number, and it's rather large.
That's massive. You're not cracking that.
Indeed, there's no way to guess it. So now, let's see if we can submit our form. And we can.
Sweet.
Let's go ahead and fix up all of our forms. The one that we'll have problems with is this delete because of the way we handle it, and we'll talk about how to fix that as well. Let's go ahead and go back into our users controller and add validate anti-forgery token on every single request that's posted, which is our edit and our reset password and our delete. Now let's go into our edit form and add in our HTML anti-forgery token. Then let's go into our reset password and add our anti-forgery token. All right, so how are you feeling about that?
I'm feeling pretty good. And I'm blown away again that some of the quickest, easiest thing we've done has been security, and yet is probably the most important. I really hope that sinks in with everybody. Don't skip anything here. Do it the right way.
Indeed. And it's like Steve said, it really is straightforward. I mean, we just have to add in this one bit of code and this bit of code and we're done. Let's look at our delete. So I'm going to go ahead and refresh, and I'm going to try to delete something. We're going to get an error. So to fix this, we're going to have to write a little bit of code that will allow JavaScript access to our anti-forgery token from within the website so that it could post it along inside of its post.js file. Remember, we created this forms.js file that includes a method for posting to a link, essentially. But we need to add in the anti-forgery token. How do we do that? Well, it's actually a two-step process. First of all, I need to be able to generate the anti-forgery token into a form that JavaScript can access. To do that, I'm going to go into my layout. I'm going to go all the way to the bottom, and I'm simply going to create a form, and I'm going to go ahead and give it the class of hidden, because I don't want the form to display. I don't really care about anything inside the form except that I have an HTML anti-forgery token inside of it. That's all I care about. Finally, I'm going to give it an ID of anti-forgery form. This way, I'll be able to use JavaScript to reach in and grab the value out of the anti-forgery token and pass it along into our request. So going back into forms.js, what I have to do is I need to add an additional input into this form. So how do I do that? Well, I can simply say append input with type equals hidden, name equals something, with the value of accessing our anti-forgery form, finding its input, and grabbing its value. Let me go ahead and break this code up a little bit. I'm going to introduce a variable for my anti-forgery input, and then I'm going to put this into a variable for my anti-forgery token. Just so the code is a little bit more clear. The last piece of this puzzle is to come up with the name. I can actually come up with the name by copying the name out of my anti-forgery token input. So what I'm going to do is I'm going to say attr name anti-forgery token dot attr name. Then I'm going to set the value to anti-forgery token dot val. Now, instead of finding this and getting the value out of it, sorry, I'm jumping around just a tad. I'm going to do that.
That looks a lot cleaner.
Yeah. So we get the anti-forgery token input field, then we create a new input field with the type equals hidden, with the name of whatever we had in the anti-forgery token field originally, and then we set the value to whatever we had. So if I come back into the code and hit refresh, we'll notice that we're generating an anti-forgery token all the way here at the bottom. And what's going to happen is whenever I hit delete, it's going to copy this input into the request and send it off to the server. So now I can delete this guy.
That is really slick. Nice.
So that is how we can use anti-forgery token with JavaScript code. So I think that just about wraps everything up. The one last thing we got to do is commit our code. So I'll go ahead and do that by jumping into source tree, staging all of my changes, and committing as prevented CSRF attacks. And I think that just about wraps up the video.
Excellent. Let's move on to the next new subject.